Hello everyone, this is Manohar Reddy, Department of Cybersecurity, Institute of Aeronautical Engineering. Today, in this session, I am going to explain you the concept of TLS architecture. So, TLS stands for what? Transport Layer Security Architecture. So, we already said that to provide the security services in the web, we are offering three types of services. First one is what? Providing IP security services. Providing IP security. So IP secure as a one type of service. So providing this IP secure above TCP, below TCP layer. Below TCP layer. So below TCP layer, providing IP security as one web security service. And the second one is what? Above TCP layer, providing TLS or SSL as a service. Providing TLS or SSL as a service. And third one is what? Application specific security service. Third one is what? Application specific security services. So each and every security service is offered based on the application type. So from this, we said that TLS, Transport Layer Security, is formerly known as SSL below 1990s. Below 1990s, it is named as SSL, Secure Socket Layer. So now the TLS, Transport Layer Architecture, Transport Layer Security. So what is meant by TLS and how the TLS architecture contains and what is the protocol stack? So TLS is nothing but what? Transport Layer Security. So TLS is an internet standard that evolved from a commercial protocol known as Security Socket Layer. So when TLS comes as a commercial protocol, so before commercial protocol, SSL is a open source protocol. SSL is a open source protocol. After 1990s, it is commercialized, and this commercialized protocol is called as TLS. So transport layer security is the internet standard commercial protocol. And TLS is a general purpose service implemented as a set of protocols that rely on TCP. So TLS, Transport Layer Security, is a general purpose service that implemented with a set of protocols that rely on TCP. That means that all the protocols are depending on TCP. So TLS could be provided as part of the underlying protocol suite and therefore be transparent to the application So TLS can be embedded in specific packages. For example, most browsers come equipped with TLS. Most browsers are inbuilt with the TLS, and most web servers have implemented with the protocol. So from this, we can say that TLS is a set of internet standard protocols and that relies on other protocols. And it is a internet standard commercial protocol. After 1990s, it comes as a commercial protocol. So here we can see the protocols which we have. So the transport layer security protocol contains all the different protocols like this. So this is the TLS protocol stack. What? So handshake protocol, change cipher spec protocol, alert protocol, HTTP protocol, heartbeat protocol, record protocol, and TCP protocol, IP protocol. So these are all the different protocols, and TLS provides internet standards on these underlying protocols. So IP protocol is one, TCP protocol is one, record protocol is one, handshake protocol is one, change cipher specific protocol is one, alert protocol is one, HTTP protocol is one, and heartbeat protocol is one. So all these protocols are presented so that we can say that TLS is a general purpose service implemented as a set of protocols, as a set of protocols. So in this TLS record protocol provides basic security services to various higher level protocols. Various higher level protocols. So higher level protocols are nothing but we already seen that record protocols, chain cyber protocol, handshake protocol, alert protocols, all these protocols. So it provides basic security service to the higher layer protocols. In particularly the hypertext transfer protocol, which provides the transfer service for web client and server interaction, and this can operate on top of TLS. So above TCP, TLS is there. Above TCP, TLS is there. Above TLS, this web client or server interaction, and these are participating as a transfer service for the web client and the server interaction, and that can operate on top of this TLS. So it operates only the top of TLS. Three higher level protocols are identified and defined as part of TLS. So those three are what? Handshake protocol, change cipher specific protocol, and the alert protocol. So handshake protocol is one, intimating that all the messages are connection oriented or connectionless or disconnected or something. Change cyber specific protocol for authenticating purpose or confidentiality purpose. And alert protocol is presented for giving the alerts or informing the messages or giving the alerts or giving the messages to the all layers. Giving the messages or giving the alerts to the all messages. So two important TLS concepts are the TLS session and TLS connection. Transport layer session and transport layer connection. So the connection, TLS connection, is one concept that compromised for connecting the system. That compromising for the connecting the system or connecting the services. So the TLS connection is established only for the connecting the services or connecting the systems. Connecting the services or connecting the systems. So which are defined in the specific as follows. Connection. So a connection is a transport that provides a suitable type of service. So it provides a suitable type of service. So for TLS, such connections are peer-to-peer relationships. Peer-to-peer. So the peer-to-peer is nothing but host-to-host connection, host-to-host connection, or host-to-network connection, or network-to-network connection. So host-to-host is one type of peer-to-peer, host-to-network is one type of peer-to-peer, and network-to-network is also one type of peer-to-peer. So the connection provides a service in between the peer-to-peer relationship. If those two are not having any relationship, they may not able to provide the connection in between those two. So those two are not having any relationship, then the connection in between those two is not going to be established. So the connections are transient. Every connection is associated with one session. Every connection is associated with one session. So the session. So what is meant by session? A session is nothing but TLS session is an association between a client and a server. That is nothing but a type of relationship between client and a server. Once the client and the server has established a connection, so client and server. So client is there, server is there. So if client and the server is established a connection, then the TLS session will be started. TLS session will be started. So the TLS session is nothing but association between these two, client and server. So this is the association, and this association we can call it as TLS session. TLS session. And the sessions are created by the handshake protocol. So the sessions are created by handshake protocol. So handshake protocol always giving the messages to the client and the server. Client and the server. Always they are giving the messages to the client and the server. If client is not requested to the server, then it gives a message to the server. If server is not responded to the client, then the message is given to the client. The message is given to the client. So that handshake protocol always gives the messages, handshake messages to the both the client and the server. Both the client and the server. And the sessions defined a set of cryptographic security parameters which can be shared among multiple connections. Which can be shared among multiple connections. So client uses one key and the same server uses one key. So in between them, it uses cryptographic security parameters. In between them, they uses cryptographic security parameters. They are going to be use that keys for sharing their resources. In between them, those two are used some keys for sharing their resources. And the sessions are used to avoid the expensive negotiation of new security parameters for each connections. So new security parameters for each connection. So sessions are also used to avoid some expensive negotiation of new security parameters for each connection. So for this, the sessions are going to be used. Sessions are going to be used for both connection purpose and session purpose. A session state is defined by the following parameters. So what are the parameters we are going to define the session is state? Session state. So the first one is what? Session identifier. First one is what? Session identifier. So it is an arbitrary byte sequence chosen by the server to identify an active or resumable session state. So in which session the connection is made, in which session the client and the server are going to be using the resources. So it is one byte sequence that is chosen by the server to identify that whether it is in active state or not, whether it is active in state or resumable session state or not. So if it is inactive, then okay. If it is resumed, then it make it as active. Active. Next, a peer certificate. So peer certificate, an X509.v3, the version v3 X509 is a certificate of the peer. This element of the state may be null. This element of the state may be zero or maybe null. Compression method. So compression method is one, the algorithm used to compress data prior to encryption. So the compression method is for what? The algorithm used to compress data prior to encryption. So before encrypting the data, that has to compress. So compressing the data by using some different algorithms. Compression algorithms using for compression purpose before encryption. And a cypherspec. So it specifies the bulk data encryption algorithm. Such as null, AES, etc. And a hash algorithms such as MD5, SHA-1 used for MAC calculation. So message authentication code calculation purpose. So message authentication code calculation purpose, this cypherspec is used. And it is also defines that attributes such as the hash size also. it identifies that it defines cryptographic attributes such as one type of hash size and a master secret. So there is a 48 byte secret key shared between the client and the server. So 48 byte secret key shared between the client and the server to improve their interactions, to improve their connections, to improve their connections or interactions. And is resumable. It is a one flag. It is one type of flag that indicating whether the session can be used to initiate new connection or not. It shows that it is indicating that whether the session can be used to initiate new connections or not. So these are all the session state parameters. These are all the session state parameters that indicates that. The next, connection state. So connection state is defined by these following parameters. That first one is what? Server and client random. Server and client random. So byte sequences that are chosen by the server and the client for each connection. So they have to choose the sequences. That is nothing but client and the server are going to be having some sequences, some sort of sequences. So connection, the first sequence, or rejection for the second sequence, or utilizing for the third sequence, or disappearing for the sequence. Like that, all the sequences are used randomly between the both client and the server. Client and the server. And the server write max secret. Server write max secret for informing to the client. So the secret key used in MAC operations on data sent by the server. So when data is sent by the server to the client, automatically one secret key is generated for this MAC operations. So automatically one secret key is generated for the MAC operations. Where we can generate this one? We can generate in the server. So that server write MAC secret. So that means server generated secret key used for MAC operations on data sent by the server. Similarly, client write MAC secret. So same purpose. The symmetric key used in MAC operations on data sent by the client. So whenever the data sent by the client to the server, automatically client also generate one key. So that key is nothing but what? Client with MAC secret. And server write key. So the symmetric encryption key for data encrypted by the server and decrypted by the client. So now server what doing here? Server generated a secret key for the MAC operations one time, and similarly client also generated a symmetric key for MAC operations one time. So now server generated one key for MAC purpose, and similarly client generated one key for MAC purpose, right? The next, server write key. That means a symmetric encryption key for data encrypted by the server. So the server has to be encrypted some data that is done by symmetric encryption key. So that means server generated encryption key for data encryption process, which is decrypted by the client. That means the server generated a encryption key for what purpose? For data encryption purpose. And that encrypted data is decrypted by what? Decrypted by the client. So client write key. So the symmetric encryption key for data encrypted by the client. Symmetric key encryption key for the data encrypted by the client and decrypted by the server. So client and the server is going to be interacting with a different sequence. So for each and every sequence, For each and every sequence, they are generating some keys. They are generating some keys. So for operating MAC operations, one key generated by both the client and the server. And for encryption purpose, generating key for encryption key for both the client and the server. And similarly, initialized vector. So when a block cipher in CBC mode, so cipher feedback mode is used. An initialization vector is maintained for each key. Initialization vector is maintained for each key. So this field is first initialized by the TLS handshake protocol. So this key, whichever is the initialization vector having the key, initialization vector, the vector represents all the keys in the form of matrix. Vector represents all the keys in the form of matrix, generated. So which is generated by what? Which is generated by TLS handshake protocol. Which is generated by TLS handshake protocol. Thereafter, the final ciphertext block from each record is preserved for use as the following record. Use as the IV with the following record. So that is initialization vector with the following record. So that following record what? Sequence numbers. So each party maintains separate sequence numbers. For transmitted and received messages for each connection. For each and every connection, for each and every operation, sequence of operations, automatically the sequence contains the sequence numbers. Sequence numbers. So when a party sends or receives change cyberspec message, the appropriate sequence number is set to be 0. And it may not be exceeded by 264 minus 1. So these are all the connection state parameters. So once the connection is established, once the TLS connection is established, automatically the client and server are going to be interacted manner. So at this interaction, each and every phase or each and every step, there is certain sequence number of messages will be there. So that all the sequences are indicating with the sequence number. So all these sequence numbers are used. All the sequence numbers are generated by this sequence number parameter, and all these messages will be displayed with the help of handshake protocol. So here server generated some keys for MAC operations. Similarly, client also generated some keys for MAC operations, and the server generated encryption key for encryption purpose. Similarly, client also generated encryption key for client purpose and encryption purpose. They are generating that keys, and out of that, server or client both using decryption keys for decryption purpose. And these all the keys are for each and every key with the numbers, with the key IDs are maintained with a matrix called initialization vectors. So these are all the connection state parameters that are having in the messages. Client server interactions are client server applications. So this is the this is the TLS connection state and the connection. The TLS connection state session and the connection parameters. So once again, we revise the topics which we discussed in this session. So here, the first one is what? Transport layer security. So what is meant by transport layer security? So it provides additional security above the transport layer. It provides additional security above the transport layer, and it is a commercial protocol from 1990s. After 1990s, security socket layer. So after 1990s, the security socket layer is became as a commercial protocol, and this TLS is a general purpose service that implemented with a set of all protocols. Set of all protocols. So that set of all protocols indicating that what? Handshake protocol, change cipher specific protocol, alert protocol, HTTP protocol, heartbeat protocol, record protocol, TCP protocol, and IP protocol. So all these protocols are underlaid to provide the security for the transport layer. To provide the security for the transport layer. So hence that TLS is implemented. TLS or SSL is implemented as a security service. As a security service above above TCP layer. Above TCP layer. So for all the client and server interactions, all these protocols are present. All these protocols are present. So the higher layer protocols are defined as part of TLS. The three protocols are what? Handshake protocol, change cipher protocol, and the alert protocol. One is what? Handshake protocol, change cipher protocol, and the alert protocol. So handshake protocol initiate the connection and informing the messages to the both client and server interactions. So it initiates the connections and it informs the messages to all the client and the server for the applications. And the second one is what? Change cipher spec protocol. Change cipher spec protocol is for doing encryption and decryption purposes. Is for doing encryption and decryption purposes for both client and server to generate. For both client and server to generate what? To generate encryption keys and decryption keys. To generate encryption keys and decryption keys. And the alert protocol informing the messages or alerts regarding the connections and regarding the sessions. Regarding the connections and regarding the sessions, alert protocol gives some sort of messages. So here two important TLS concepts are there. One is what? TLS session, and the second one is what? TLS connection. Or else you can say that TLS connection is one and TLS session is one. So here the connection is a transport that provides. A connection is nothing but what? A transport service that provides a suitable type of service. Suitable type of service that is nothing but it made a connections in between peer-to-peer relationship. It made a connection in between peer-to-peer relationship. So the peer-to-peers are nothing but what? Host-to-host relationship. That means host-to-host connection establishment, host-to-network connection establishment, and network-to-network connection establishment. Network-to-network connection establishment. So each and every connection is associated with one session. Each and every connection is associated with one session. And this session is what? Session is nothing but what? A association between client and server. A relationship between client and server. So at what time the connection is established, at what time the connection is going to be active, at what time connection is going to be inactive, and at what time connection is going to be terminated. All these informations are maintained in this session. So sessions are created by handshake protocol. Sessions are created by handshake protocol. So here the session having some sort of parameters like session identifier, peer certificate, cipher spec, master secret, is resumable. So these are all some sort of parameters that are used for session state. And also connection state parameters. So connection state parameters also there. So for each and every connection, for each and every session, the separate parameters are there. So here also server and client are interacted with the help of some messages, with the help of sequence numbers. They are generating some encryption and decryption keys, generating some keys for MAC operations also. So these are all the different types of parameters for both connection state and the session state. Those two are the TLS concepts. TLS concepts that are used for the transport layer security services. That are used for the transport layer security services. So that's all about this TLS architecture and TLS concepts by connection and session state. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.